Alright, so getting ready to start section 3.3 here, formula weights. Same molar mass, right? Same thing as molar mass. So one of the big things about molar mass that you need to know is anytime you need to calculate, let me write that a little cleaner for you. Anytime you need to calculate molar mass and it seems like you don't have everything you need, remember that all you need to calculate molar mass is grams and then however many moles that grams is. And so that's one thing that we'll see a lot throughout the year is we'll be asked to calculate molar mass. You'll be given a grams and then maybe somehow in a problem you'll figure out how many moles that grams is, and then the molar mass is just the grams divided by the moles. So always keep that in mind. We'll do a couple molar mass here. So technically, if you're talking about an ionic compound, you're talking about the formula weight, and if you're talking about a covalent compound, you're talking about the molecular weight, but generally molar mass is good for everything. So let's go ahead and take a look at sucrose here. We've got C12, H22, O11, so I'm sure you guys are okay with this. You've got 12 carbons, 22 hydrogens, 11 oxygens. Don't round anything. Okay, so when you punch that into your calculator, make sure you don't use 12 for carbon, you're using 12.01 or whatever is on the periodic table that you're using. So in this case we have 144.12, 22.176, and then 176. And so I got the molar masses from the periodic table. Carbon weighs 12.01 on mine. Hydrogen is 1.008, and oxygen is 16.00. Okay. Then I just add all those up. And I get a value of 342.296. Now I want to have 4 significant figures. All of my weights have 4 sig figs, so I would want to actually put this at 342.3, and that's grams per mole. Units are important. Make sure you're putting units in with everything. Let's do calcium nitrate just because it has that parentheses there. Sometimes people make mistakes on parentheses. So here's calcium nitrate. So for this we're going to take calcium. We have one of them. So I'm going to take 1 times, calcium is 40.08. I've got 2 nitrogens. So I'm going to take 2 times 14.01. And then I've got 6 oxygens, which is 6 times 16. And then just again add all those together. Which is 164.1 grams per mole for calcium nitrate. The big mistake that I always see is that students will add these instead of multiplying them. They'll get 2 nitrogens and 5 oxygens, so the 2 plus 3 is 5. It's multiplied, so make sure you don't make that mistake. Everybody good with molar mass? Percent composition, it's used a lot throughout the year, believe it or not, percent composition is. And make sure you know what you're doing. Is it percent composition by mass or percent composition by moles? Because it's 2 completely different things. So the percent composition by mass, let's go ahead and do that first. So on this one, C12H22O11, we already did the molar mass of it on sample exercise 3.5. So let's get the percentage of carbon. So I want to know what percent by mass of this compound is carbon. So I'm going to take the carbon atoms, which is 12, and multiply by the atomic weight of that carbon atom, which is 12.01. And that's actually divided by the molar mass of everything. So in this case, 342.296. So just to give you a heads up of what we're doing here, we're taking 12 times carbon over C12H22O11, and that's by mass. So I'm taking the mass of those. And then I'm going to take that times 100, because it is a percent. And I get 42.1%. That's how much carbon is in a sample of, what is that, glucose? Sucrose. Sucrose. Okay. Right. So that means if I had like 3.8 grams of sucrose, I could figure out how much carbon I have by taking that 3.8 grams and multiplying by 0.421. And that's going to give me 1.60 grams of carbon. So that's how much carbon is in 3.8 grams of sucrose. If I'm going to do a hydrogen, I'm going to do the exact same thing, except I'm going to have hydrogen here on top. If I'm going to do oxygen, same thing, except I'm going to have oxygen on top. So that's percent by mass, which we use percent by mass often. Not as often. I'm trying to erase the yellow, it's just not erasing. We can, on occasion, use percent by moles, which is a little bit different. So percent by moles, so this is by mass. Still, it's percent. So percent by moles, I'm going to take 12 carbons over 55 atoms. And I got the 55 by taking 12 plus 22 plus 11. And then times 100. And that's going to be percent of carbon by moles. So I get like 21.8% carbon by moles. Now, you got to be careful with this because it's by moles. So if I have 3.8 grams of sucrose, I can't figure out my percent of carbon by moles if I have 3.8 grams. Now, if I had something like 0.034 moles of sucrose, then I can figure out my moles of carbon, because I can multiply by 0.218. That's carbon by moles. And I can get that I have 0.00742 moles of carbon. Because that's the percentage of carbon by moles. And again, you know, just make sure your units match. If you're given grams, then you want percent by mass. If you're given moles, then you can use percent by moles. But they have to match. You can't take your grams times your percentage by moles. Alright. So we did molar mass, formula weight, atomic weight. You know, it's all sort of built in together. The difference is like if you're talking about atomic weight, you're talking about just the atoms. If you're talking about formula weight, you're again just talking about the atoms. Molar masses, you're talking about a mole's worth of the compound. And we know that a mole is 6.022 times 10 to the 23rd. And that a lot of values are given to you on those constant sheets that you'll get like the first or second day of class. So, you know, that's one of them is the Avogadro number. So 6.022 times 10 to the 23rd, that's how many things are in a mole. And we say that 12 grams of carbon-12, so that's a very specific isotope, 12 grams of carbon-12 has exactly Avogadro's number's worth of atoms. So it has exactly 6.022 times 10 to the 23rd atoms in 12 grams of carbon-12. The AP, they don't often write grams per mole like that. They'll do grams, moles to the negative first. So just be aware of that. I use that a lot too, just so you're comfortable with it by the time we get around to it. Okay, so let's do some simple things here. Calculate the number of hydrogen atoms in 0.350 moles of C6H12O6. So I've got 0.350 moles of C6H12O6, and I want to know actual atoms. So not moles of hydrogen atoms, I want to know actual atoms. There's a couple different ways that you can do this, and start letting the dimensional analysis, factor label method, T-chart, start letting that sort of guide you of what you want to do. So now I have moles of C6H12O6. I want to end up with atoms of hydrogen. So what do you want to convert first? So there's a couple different ways that we could do this. I'm going to go ahead and convert my moles of C6H12O6 to moles of just hydrogen. Okay? So I'm going to leave the word mole. I'm going to get rid of C6H12O6 and I'm going to pick up hydrogen. So that cancels that out. What's the relationship between hydrogen and C6H12O6? How many hydrogens, how many C6H12O6s? Yeah, I've got 12 hydrogens for every one of those, right? So I can go ahead and calculate that out, or I can write one big long problem. Doesn't matter as long as I don't round and round and round again. So this gives me 4.2. I didn't touch the word mole, so that's moles of hydrogen. Now I want to convert to atoms of hydrogen, right? So I don't want to touch the H. I don't want to touch the hydrogen. I want to get rid of the word mole right there. So now that's gone. And I'm going to replace it with the word atom. And so I have 6.022 times 10 to the 23rd atoms in 1 mole. Don't forget to use your EE button, your times 10 button. I'm going to go with 3 sig figs here. So that's how many atoms of hydrogen I have. Okay, so let's put a circle around that. Any questions there? We're doing that? Okay, let's do the next one. Next one's a little more what you've seen in the past. So we have, it says calculate the number of moles of glucose in 5.380 grams of C6H12O6. So I've got 5.380 grams. And I want to convert that to moles. Right? So I'm going to put grams on bottom, moles on top. Anytime you see moles over grams or grams over moles, you have molar mass. Right? So the molar mass goes here. And it's always the molar mass of whatever is in front of it. In this case, C6H12O6. I think weighs like 180. But we'll go ahead and get the actual mass. So 6 times carbon which is, I believe, 72.06. 12 times hydrogen, which is, I don't know off the top of my head, 12 times 1.008, that's 12.096. And then 6 times oxygen, 1632.96. Add all that together. I get 180.156 grams per mole. So 1 mole for every 180.156 grams. And I get a value of 0.0299. Grams cancel out. So that gives me moles of C6H12O6. Alright, any question on that one? We comfortable with this? For the most part? Alright, let's look at another one. Come up with the formula for calcium nitrate without looking back at the other notes. We've got a chance here to try it out. Alright, calcium nitrate is a CaNO3 2. So we're converting from moles to grams in this case, so basically the opposite process. So we have that many moles of calcium nitrate. I want to get rid of the word mole. I want to replace with grams. Grams over moles or moles over grams. You're talking about molar mass. So again, this is molar mass here. And it's the molar mass in this case of calcium nitrate. So I'll go ahead and get that over here. Calcium is 40.08. I've got 2 nitrogens, which would be 28.02. And I got 6 oxygens, which we've seen is 96. So I get a value of 164.1 grams per mole. So for my final answer, moles cancel out. I end up with 71.1 for 3 sig figs. That's grams of calcium nitrate. Any questions? Charge. Where are we at? Okay. We're doing okay. Alright. Try this last one here. We have 5.23 grams of that glucose still. We're asked how many molecules we have. So let's see. We have 5.23 grams of C6H12O6. And I want to convert it to molecules, so I don't have any conversions that I can go from grams to molecules, because I don't know how much a molecule weighs, right? I don't know that. I know how much a mole weighs, but I don't know how much a molecule weighs in grams. So what I'm going to do first is convert this to moles. That's right there. Again, grams over moles or moles over grams. We're talking about molar mass. We already did the molar mass of this on problem 3.10, so it's 180.156. So 1 mole weighs 180.156 grams. So that'll get me moles of the compound. Which is 0.0290. Use the actual number that's in your calculator, don't round it. And now I want to convert from mole to molecule because I know how many molecules are in a mole. Mole goes on bottom, molecule goes on top, and it's 6.022 times 10 to the 23rd molecules in every 1 mole. Oh, I got point. Sorry, I wrote this down wrong. It's 0.0290. Sorry. So I get a final answer of 1.75 times 10 to the 22nd. I don't know what that's doing. Thank you. Get off there. Times 10 to the 22nd. And that's molecules, because moles cancel out, of C6H12O6. Any questions? I think I want to start that.